Hi, good morning, everybody. I'm Joanna Smith, and here we're going to talk about idle modes. I know you're all really excited, and you definitely don't hate these, and you're definitely not frustrated, so this is going to be a very pleasant experience for all of us, right? Right? Okay, great. So the greatest thing about the next half hour, 45 minutes of your life is you're going to sit here and listen to me talk and not get to say anything, and then you're going to walk out of the room thinking, great, I don't have to do anything. I'm exactly at my status quo from before the talk. So definitely productive use of your time. And the reason you're going to want to listen to me, you could read my online bio if you want, I don't really care. But specifically, I'm a developer advocate for Android, and I've been working a lot on trying to educate people about best practices. We have a lot of resources out there for you to learn how to use an API when it's launched or how it works, but nobody's really trying to teach people when to choose an API or how to use multiple pieces together. And so that's why myself and Ian Lake, who's speaking right after me, launched Android Development Patterns. So we have a series of videos and pro tips online so that you can learn how to bust bad behavior and how to make your app better. We also created the Advanced Android App Development Udacity course. So if you're trying to tweak your skills or work with something a little more complicated, or you want to have a whole lesson on how widgets work, we're your people. And then the other thing I want to say about me personally is I started learning Android in February of 2014. So I'm not even quite at 2 years, and yet I'm up here, representing our engineering team, trying to teach other people about best behavior. And I say that because a lot of people get really intimidated learning a new language or a new skill set, or if you come from a Java background, Android's life cycle doesn't make a lot of sense, and it can be overwhelming, especially when we change everything every year. And so I just want to let you know, don't give up hope or don't get frustrated. There's a lot out there, but you can be really exceptional with without understanding everything back to Froyo, basically. Okay, so let's get started. The reason that I'm here today specifically is because battery is one of the most important things that we need to talk about, both from our side as providing an operating system and from your side as developers, right? This is the biggest problem in mobile. People get so frustrated about this. They're constantly trying to measure their battery as a consumer or figure out what's eating all of their battery or why their phone has to be charged twice in a day. Users hate this. And then they hate you because they don't understand what you're doing or why you're coming up on top all the time. And then they hate us and they want to get a whole new phone, right? So there's a lot of press about battery, tons of studies that you can find just from any kind of search on your favorite web engine. And it's a problem that everybody wants to solve. But the problem is when somebody tries to give you blanket advice, they'll tell you things like just don't have lingering services and don't do background services and don't use memory and basically don't be an app. When the truth is, you want all of those things. A device naturally will launch an activity, and that activity should be using background services. One of the most important things to keep in mind when building an app is that we call our main thread the UI thread for a reason. Everything that you do there affects what the users see, and if you miss your frame rate, they're going to uninstall you because they think you're janky. They don't realize that you missed your framework because you're working really hard. And we can't educate users, so you just have to fake it till you make it, right? So my point here is that background services aren't bad. What's bad is when every app has their own background service over time triggering willy-nilly. We need to coalesce these together so that we can create a good experience for the battery, because if you only use the radio twice in a day, but you use it separate from everybody else, the radio never gets a break. And that's not good for network, that's not good for the device. And so, because we can't really teach people how to do this work with other apps because you don't have insight into other apps, we're going to force you into my favorite mental model. And that's what Doze is for. So get comfortable with this image. I know it's really complicated and hard to remember, and you're not going to see it again, so you really have to work hard. But the idea here is over time, I want every app's background job and sync to line up in batches, because then we can turn the radio on once. It doesn't particularly matter for most apps if their sync happens at 6 p.m. or 8 p.m., so let's take advantage of that flexibility. And that's what Doze is for. So we'll go over that first. Doze was introduced in Marshmallow, but it doesn't really matter what API you're targeting because Doze is going to affect every Marshmallow device, even if you're still rocking that lollipop. Okay, so you have to get understanding of this because you have no control over what device your users have, right? So you would think that with something as big as Doze, we'd have a lot of goals for it, but the truth is we only have one. We want to preserve the user's battery life. That's our one goal here. We want to create a better user experience by making sure that when the user puts their tablet down and goes off to Cabo for a week, they come back, pick their tablet up, and it's still alive. They weren't using it, so why did it die? That doesn't make any sense, and so we're here for that. But the truth is, like I said, we can't really get you to work kindly with other apps because that's not really a possible situation here. So we forced you, and people don't really like that, and that's why there's a lot of very kind comments on Twitter that definitely aren't frustrating at all. And so before we can really get into more of the why here, I need to explain my goal for you, which is this. You aren't as important as you probably think your app is, because as a developer, your mind is in the zone of thinking about your app all day long. You kind of go to sleep thinking about that problem you want to fix, and you wake up thinking, oh gosh, no, this bug too. It never leaves your head. Whereas with your user, they're not going to use it all day, every day, right? And you need to come to terms with that as a developer. So my best example of this is a success metric. So our fearless leader is Larry Page. He's pretty great. And he defines success inside of Google by a toothbrush metric. So if your product is used twice a day for about a minute each time, you are insanely successful and worth investing a quarter of Google's resources in. That is something that's going to hit home and be great and change the world. So that's 2 minutes a day, right? Which means that there are 23 hours and 58 minutes that the user isn't using your app or your product, and you're still a grand success that Alphabet would invest in, right? That's perspective, right? And it's hard to keep that in mind when all you do is create your app. So 23 hours and 58 minutes. You have to be willing to recognize that users exist outside of you for all of that time, and you can be a little bit more flexible about when exactly your background sync is happening. That being said, let's go into exactly what Doze is. Doze is when your device is fully idle, but not really sure what that means. So what happens in Doze mode? First, network access is suspended. The whole point here is we don't want the radio going off. We don't want it going off every 5 minutes. We don't want it going off every 15 minutes. We want to do this in a controlled setting when we can. So network is off. You're just going to have to deal with that. The second is we don't care about your wake logs. The device isn't being used, therefore you really shouldn't be doing anything. This isn't, I'm going to send a notifications to get the user's attention. This is, they're not even in the room. It's not happening. They don't care about the device. You shouldn't care either. So along that same vein, all your alarms are delayed. Now we understand that alarms are a great way for you to control the flow of your app. So we're not deleting your alarms. We're not dropping your alarms. We're just going to hold them off until the Doze mode is over, and then they'll all trigger, and you can react to each one the way you normally would in a nice batch. And then the most important part, syncs and jobs are not going to run. But this is the same deal. We aren't deleting your background jobs and syncs. We're not making sure your app doesn't ever get a chance to exist. We're just controlling when they're going to happen, which is when the device is active. We also, I have to mention, have these periodic maintenance windows that I'll go into further detail, so that prolonged Doze periods still get a chance for you to run periodic updates at least once a day. Okay, so then now that you're all worried and you're like, wow, they hate us and my app's going to die, let me tell you how we even get into Doze mode and why it still doesn't matter for your app. Doze is going to be triggered when the device is not charging, right? Because we care about battery, so if we're plugged in, we don't care about any of this. We're not at risk, we're not worried, we're not concerned. There's power coming from somewhere. So the device is not charging, it's out there draining the battery, and the screen has been turned off, so probably they're not interacting, but most importantly, it's not moving. There's a difference between having your phone in your pocket and it going idle, which would be awful when you need to navigate somewhere, and having it down on the counter as you come up here to give an hour-long presentation, right? One of them I'm going to respond to a text message, and the other one probably not. Okay, so these three states. We've really put a lot of thought into this, and you'll see why as I continue to talk to you. So let's take a look at this beautiful image that you probably recognize from our documentation about Doze because you totally read all of our docs and you're really excited about it. This is an estimation of a timeline of how Doze works. We have this nice long period where we're idle right at the end, and these nice orange bars, which represent those maintenance windows that you'll start to understand later on. And then we have these crazy spikes at the beginning, and all of those crazy spikes represent normal usage of the device. And that's the period when the user is using it, and we're trying to determine if we have reached idle mode and if we're there yet, and how confident we are that we really should be idle right now. So normal usage, which if it happened all day, would drain the battery in hours? Okay, so the reason we have this nice long period of normal usage, even after we might have started thinking about Doze, is because we want to hit that confidence level. And to do that, we have states. So we don't just jump straight from active to idle. We walk ourselves into it. And we do that with the device idle controller class. So this class was introduced in the Marshmallow Code. It's pretty fantastic. And it's part of the AOSP. So you can read about it and figure out what's going on and understand everything on your own. Or you can trust me, or you can find someone else who wrote a blog on it and read their blog. Okay, so there's several states. The first and easiest is active, right? Because If we're active, then we know that everything's working properly and like they're using their device and your app is going to run exactly as expected, and that's just great. Then we hit inactive, and this is when we've noticed that the screen is off and the device isn't moving, and all those conditions for Doze have been met, but like we don't really know why yet. We're just like, okay, great, we're not active, we're just chill with this. And then comes an idle pending state, which is, okay, we weren't active, it's been a period of time, we're still not active, let's one more vote of confidence, like we're getting close to there. And we have to go through this before we can ever even get to our idle state, right? And the beautiful thing about this is you can read the class in the AOSP and you can see how we get there. And it's really easy because Device Idle Controller has an alarm manager that triggers its own alarm so that it can track its own progress. And so we wait about 30 minutes between each alarm to see, have we gotten out of this? Like, are we good? Like, did something happen? Are we moving? Like, is there some new foreground service? Like, what's going on? And then we use those half-hour periods to see, like, do we need to back up or do we move forward? So there's a very long time to be comfortable if the user's really not interested before we get to idle. And that way, you can trust our comfort levels. You can know if they're comfortable if the user's not coming, I can be comfortable if the user's not coming, and I don't have to panic and think my app is going to be ignored, because we care about our developers even when you're upset with us. Okay, there's also a state called idle maintenance, and this one's really cool because this is that maintenance window that we get to. So if we have a really long Doze period, we understand that you probably want to like have updated information for whenever the user comes back. So we let you run your jobs and syncs all in a batch to get to our beautiful timeline of our mental model that you definitely memorized, even though it was so complicated. And we're going to be able to batch run all these jobs so that you're up to date when we finally get out of idle mode. Okay, so those batch windows, that's what that idle maintenance means, these nice orange thick spikes later on. And your mental model, because I forgot it, right? You all forgot it? The super complicated mental model of what we're trying to get over time is these batch syncs and jobs from different activities. So this is our ideal world, and you definitely won't see this again, so memorize it this time. Now, all of this being said, you want to know how these states work, right? Like, you want to see for sure that you can trust us. And we made this super cool ADB service that you can step your app into them and see what's going on. And it's super easy to run. You just need a Marshmallow device or emulator. Your app needs to be running. And then you need to tell the ADB, like, unplug, so we're outside of the charging mode. And then dumps this, you've probably seen before. It's a binary that lets you call other services by name. And then device idle, that's your new service. And you can step through each state, see what's going on, or you can ask for help with any other like command line service. It's so easy, super easy to use, and you can test your code to be like, okay, great, like they weren't lying. And you can also, look for surprises to see whether or not we really did mess you up, and then you can go on Twitter and yell at me some more. Okay, so how do you get out of Doze mode? Well, it exits when pretty much the reverse of everything else that caused us to enter happens. We plug it in, so everything gets released from Doze mode because battery's totally safe now, or we pick the device up because the user has come back and they want to see what's going on, or, and this is the cool one, an alarm is going to go off. And I don't mean an alarm like Alarm Manager, because now you're wondering I lied before, and you're like, wait, you said you don't listen to those. I mean like an alarm. Like, I set my alarm clock, and I need to like remember to get back to work by like the time for my meeting, and otherwise I'm going to get in trouble. Or I'm going to miss my doctor's appointment. Like, users need alarms. So what we do is when we have an alarm clock pending by our app or one of your apps, like something that's registered as an alarm, then we wake up from Doze mode a little bit before, everybody runs their sync, then the alarm goes off, the user wakes up from their nap and can see all of their updated news, weather, and traffic, right? Look how smart we were. See, we hear you guys. You just, are still a little upset, so that's okay. So how do you not do anything? Well, your app should work. Like I told you, nothing gets dropped, nothing gets delayed, nothing gets deleted. It's all like maybe a couple hours off, but the user didn't notice, and you won't notice, right? Like everything's good. But if you have something special, you can adapt, right? A couple simple things that you probably don't need to do, but I'm going to tell you how to do them anyway. So the first is you need to think about your app's architecture. You need to understand what it's doing and what it's expecting. Because if you have something kind of weird, like your server relies on your client to check in every day at 6 p.m. for an update, then probably that's not going to be great, because if you miss that because you're in Doze mode at 6 p.m., then your server's going to panic. But then again, you shouldn't be doing that anyway, so that's on you. And you should use downstream messaging. It's just a general best practice. That way your client is always the one reacting instead of the server. But if you're using downstream messaging, and specifically Google Cloud messaging, which you should be using anyway, and I can tell you about that later, then you can add a high priority tag. And this is great, because anything with a high priority, the system will receive, and then they'll be able to say, okay, great. Temporary wake up for the app, they can react to this high priority message and be able to respond appropriately in case it actually is something important, like a text message if you're like a messaging app, because something from your mom you might actually want to work out here. Now, people are probably going to think, this is great. I'll add high priority to every message I send, and I say, you suck, and you're ruining the whole process, so please don't do that. Great anecdote for you to keep in mind. If it's a high priority, then it's worth getting the user's attention, right? Which means stop being a developer for a minute and think about your user selves. Are you going to get up out of that chair, cross to that side of the room, pick your phone up off a table and look at it and groan? Or be like, okay, good, nice to know. Because if you have to walk all the way over there to look at a notification and it's just something that like you got 100 new points in your game, you're going to be really frustrated with that app and probably uninstall it, right? But if you walk over there because your mom wants to know what kind of pie you want for Thanksgiving and she's baking it tonight, then that's important. That's super important, right? So there's your method to tell. Is it high priority? Do I walk across the room and I'm upset? And you as developers, you really don't want to get up from your computer and stop coding, right? That's your metric. And if you can keep that in mind, you're going to be super successful. Okay. So the other thing you can do is, I kind of lied when I said we ignore all of the alarm manager alarms. We actually have these exceptions. Your set and your set exact methods have a new counterpart called set and allow while idle, or set exact and allow while idle, which, surprise, surprise, allows the alarm to go off while we're in an idle mode, right? Super, super great naming. Okay, so these are really great if you actually do have something time critical. Like maybe you want your calendar app, or you're going to trigger a notification in advance of some event that is really important to the user and they can't miss that. So we give you this opportunity. Wake up your app a little. You still don't have network access and you still can't run your background services, but you can wake up, react, produce a notification, trigger a sound, everything that the user would care about. So as far as the user can tell and as far as you can tell, there's no change in app behavior, but you're still able to do and accomplish everything you want, and we're still able to preserve our battery. So the other thing to know about these is you can't just go willy-nilly changing every alarm you have, because if you're one of those apps that has like an alarm going off every 2 minutes, this isn't going to help you because we've throttled these. Sorry, going to have to live with it. We care about battery. So one alarm will go off in a 15-minute period. So if you trigger 2 right after each other, or like in a 5-minute window, there's going to be a 15-minute delay before the second one triggers, which actually is fine. Most apps won't affect this. Like a calendar event notification 15 minutes before, and like at the moment, that's about right. 2 minutes before and 1 minute before, that's a little spammy. So again, you really shouldn't have to change much, but maybe add a couple of characters. And these methods aren't any different. The only thing that changes in creating the whole alarm, getting the instance, actually setting it, is these extra and allow while idle letters. That's the only difference. All of the parameters are exactly the same. All of your wake up and timing, everything is exactly the same. The method behaves exactly the same, but our system will acknowledge that you have something important and will give you the chance to act on that. Because believe it or not, we don't hate you, right? Like, we're trying to do the best thing for the user, and since nobody can really listen to us, we're going to force you to do it with us, but in a really kind way. Okay, and then the other thing you might want to do to adapt is to test your app. But seriously, you should have been doing this anyway, so this isn't actually adding to your to-do list. So at most, you've got like 2 halves of a step to do, like a high priority and an allow while idle. That's not really that much work, and you could have done it while you were listening to me and already be done. So you can still leave the room not having changed anything, right? Everybody's calm, everybody's good. Okay. I'm also supposed to mention that we technically have a whitelist, but I'm supposed to remind you that you probably don't qualify for it, and you need to be really careful about trying to use it because we have a very, very few special use cases that are spelled out in our documentation and are subjected to a Play Store developer policy, and it's really probably not applicable to you because we want to get to this beautiful mental model that I told you to memorize, right? And we can't do that if we have 1 or 2 apps exempted from that are constantly using the radio. It undermines the entire process. So they're being really kind of mean about the whitelist, but you don't need it anyway, because I already convinced you that your app isn't going to be destroyed by Doze mode, right? Like, nobody's scared anymore, right? Right? You might still be angry, but you can tweet at me, and that's fine, I'll take it. So let's shift gears, and we'll talk about app standby. It's kind of Doze's cousin. It was also introduced in Marshmallow, and it's also going to affect you no matter what you're targeting because it affects every Marshmallow device. Now, the cool thing about App Standby is it has the exact same goals as Doze does. It's really easy to remember. We just care about the battery. We care about a beautiful user experience and making sure that we can get that at all times. Because this is that mental model that you totally forgot by now, right? Because it's so complicated. Over time, we want every background thing to be happening in batches. And if the user's still using their device actively and we never get into Doze mode, we still want to be able to optimize for them. So what we've done is we've made a slight comparison which stands out in the sense that it affects apps. It doesn't affect the whole device. The device is still functional, but if an app hasn't been used in a while, then we're going to kind of decrease when that app has access. We're going to try to optimize all of the quiet ones. Okay, so other things you want to know about the difference before we go into this is that We're definitely restricting network access because we care about that, except now we're doing it on the app level instead of on the device level. We're still delaying all your jobs and syncs. They'll get their chance. I promise they'll get their chance, but it's going to be in a controlled way. We're going to honor wake locks, though. We're going to adhere to your wake locks, respect your wake locks, and we're going to respect your alarms from Alarm Manager. And these two things at the end, that's what's going to have made all of the difference. Because app standby is triggered differently than Doze is. So it's triggered when, again, the user's not using your app. So this is a similar idea to the device, except they just aren't opening your app. They haven't opened it all month. They're not really that interested in it. And I'm sorry, not every app is used every day. Remember the toothbrush test. Okay. Then the other thing is that maybe you don't have any active activities or foreground services. Nothing in the foreground is running. If you're streaming music, we get that's kind of important, and they're not interacting with your app, but they're listening to it for the whole course of the party. It shouldn't cut out in the middle. So foreground services and activities, those are respected. And even more than that, we respect your foreground services and activities if they were launched by another app. It doesn't have to be launched by the user, but if your app behaves in response to another app, we respect that too. Anything in the foreground is safe. But this is where our differences matter. There are no pending notifications in the lock tray or on the lock screen, the notification tray or the lock screen, which means that you actually have this really cool way of getting yourself out of app standby when it matters to your app. So let's talk about how to do that. So app standby is going to end when the user wants to use your app. That's a very clear signal to us. They want to interact with you, you're going to interact with them. Or the device is plugged in, because again, we're doing all of this for battery. So if we're plugged into the wall, everything's free. Everything is released from app standby, Doze ends, everything is free to behave as they want as long as we have power coming. But the most important is that maybe your alarm manager set an alarm, and that alarm is going to go off, and then because the alarm went off, you're going to do some sort of work in response to that, and you're going to create a notification to the user that something's up to date. Maybe at 6 p.m. there are new levels for their game available, or maybe there's new information that you want to present. So anything that would be worthy of creating a notification, that's fine. You can behave as you normally would in response to a time or maybe new information or some sort of trigger, or you just have some ads you want to display so you bring your user back into your app. We get it, you have to monetize. But all of that means you can create a notification, present it to the user, which again, you're getting their attention. So remember the walk across the room test. But as soon as you do that, you're released from app standby. Because if you have a pending notification, the user is probably going to come your way pretty soon, right? They're going to look at that and be oh yeah, I need to interact with you. So we respect that. That means that you don't need to be idle right now, and you probably need to have access to your background services or your syncs or the network so you can be ready when they open your app. See? We get you. You don't think we get you, but we thought really hard about our developers, I promise. Okay, so see this beautiful mental model that you definitely forgot because I've only showed it to you 4 times already? We want to get to this ideal world of batching, and so what we did is we created app standby. We bothered with this whole effort of making you upset with us, so you tweet at us and you're mad, and then we have to explain to you why it's okay. We went through all of this because we can achieve this mental model with app standby by offering periodic maintenance windows. So maybe your app isn't used every day. Maybe you're a once a month kind of app. That's fine, but you still need to be ready when they open your app because they're going to come back to you at some point, right? So we guarantee you a maintenance window at least once a day, if not more often, so that even if it's been 20 days since you've been used, you're ready and you're up to date and you're at most just a couple hours behind in information, right? So a guaranteed periodic maintenance window for every app in app standby means they all run together with one use of the radio. That is a huge achievement for battery. And so, sorry if you don't like it, but it's going to work really well for your app, I promise, and it's great for our users, which means it's going to be great for you and the 18 different phones and tablets you have in your house, right? Okay, so an anecdote about why we do this. Let's consider a successful app that you might not use every day, like a movie streaming app or a movie purchase, in ticketing app. These kinds of things you don't use every day. You probably wait until you're in the car, stuck you're still 7-year-old in the back of your seat while your parents drive to your grandparents' house for Thanksgiving, which will probably happen, tomorrow? That's a situation nobody wants to be in, especially as an adult. So you're going to pull out your phone while everybody else is arguing and start watching, whatever streaming you're in the middle of. And you probably haven't used it since October? And so the difference is when you're dealing with something like digital content, you need to make sure that everything is up to date, new information, new shows, new movies are all there and available on the list, or more importantly, that the licenses for any digital content that was purchased have been refreshed, because otherwise the app has to legally delete it, right? So those once a day guaranteed maintenance windows means that you're always ready in any kind of situation, no matter what your app's use case is, right? So we thought long and hard, I really promise. And if you don't believe me, you can throw any use case out you want at me, and I'll try to come up with a good answer. Okay, but this is our goal. Everyone agrees that we're getting to our goal. So you're starting to see why we had a good reason, and you only hate me like 20% now. Okay, so how do you adapt for app standby? Because you have no control over this, and you don't know when you're in app standby, and that's kind of scary. I get that, right? So again, you shouldn't have to do anything, right? Your alarms are honored, your wake clocks are honored, and your jobs and syncs will run at least once a day, which means you'll have network access at least once a day. So you're good until you're being used. But if something does come up, we get that. So hello, GCM, it's your best friend, right? You're totally convinced that you love downstream messaging with our super great service, and the high priority stands. Any message that comes through to the system with a high priority tag will mean that your app is given a temporary reprieve from idle mode to react to that. And so if that reaction includes a notification that you create, great, you're out of idle mode. But if it's just something that you need to do to speak with your server, then great, you're still in idle mode, but at least you're informed. Your client can rely on all your communication from your server that's time sensitive. And anything that's not time sensitive is just held for you until your maintenance window. So no matter what, you're not missing anything important. You're good. You guys are good to go. You're gonna be great. It's gonna be awesome. Okay, so now you've been listening to me for a while, and you're probably confused. You're like, wait, what do I do? Because my app use case has totally not been talked about, and you shouldn't have done this idle mode in the first place, you guys. Battery was totally fine. Okay, well, that's not true. This is happening. It's done. It's mandatory. Any device on Marshmallow. So time to live in our new world. I know you're really excited and you're not frustrated at all. But what you actually need to do here is believe us. This mental model. See, you totally forgot it, so I put it back up here because it's so complicated. Over time, we want everything done in a batch. We want to turn the radio on only maybe a couple times a day if the device isn't used, or only once a day if it's being used, but everyone else is doing their job sync. And we just want to do one batch for all of that. Let the user have some control here. And remember, understand when you are important and when you're not as far as a day in a life goes. So one app trying to be an exception to this undermines the whole process, which is why this is now mandatory and forced on all of you, because that's the only way we can achieve success, and you're totally going to forgive us because I'm really great and you like me. Okay, but again, your to-do list here basically includes rethinking some stuff. You need to understand what has changed. Wake locks and alarms, their behavior may or may not be trustworthy depending on whether you're in Doze mode. Your alarms will trigger, but maybe not exactly right on the moment, right? An app standby, you can still count on these. But again, the behavior has shifted, so that changes the way you think about some of the assumptions you made in your architecture. And then your jobs and your syncs might happen a couple of hours late, and that has to be okay with you. You need to make sure that your system is able to react to that. So this is what's changed. But at the same time, nothing has actually changed. Because like I said, we're not deleting your jobs and syncs. They're just a couple hours late, which for most apps is not a noticeable difference. Because most apps use downstream messaging, and they rely on the client to speak to the server to get updates, and then the server's probably not expecting a one specific moment of the day check-in. So you're probably okay. I guarantee you, you're probably okay. But let's revisit our to-do list. Think about your app architecture, right? Update time-critical alarms that actually matter with the and allow while idle. That's the only change. It's what? 40 characters in your whole code base probably? You're great. Totally easy. You might not even have to. Add high-priority flags to any downstream messages through GCM, which technically isn't an Android change, so you can still kind of chalk that up to a server-level change. So again, your to-do list is basically nothing. But then the most important thing is you just need to test your app. You need to walk through what's going on in your application, step through with our ADB service, see what the behavior is getting into and out of the idle modes, and most importantly, make sure that you aren't surprised. Because if you're surprised by some sort of behavior, something that doesn't happen when it should or something that happens when it shouldn't, then your user is going to be surprised, and surprised users uninstall apps because they don't understand what's happening and then they think that you're stealing their information or draining their battery. You don't want to be that app. Okay, and then when you've done all this and you found something that you don't like, you just repeat. See? Test your app. You notice how this is kind of just your development flow normally? So there really isn't a change, which is why I'm convincing you that you can walk out of the room being like, okay, good, status quo, no difference, right? Right? You don't seem that like you're convinced. But here's again, how to test your app. What you've got here are two super, super sweet ADB services that we created with Marshmallow that I told you, step through Doze mode, or super even easier than that is the set inactive service for app standby. You just set true or false. Set inactive, let's see what goes on. Set inactive false, okay, great, we're out of it. Let's see what happens now. You just want to test your reactions and look for surprises. And if you're not surprised, then you can just call it a week on Tuesday and go home and be like, turkey time. And if you are surprised, you can be like, crap. I'm going to go on Twitter and yell at that girl. But hopefully your apps are going to survive and they're going to be fine. And if they don't, that's okay. You can, like I said, come and yell at me. This is how you find me on G+ or on Twitter. And if you have a use case that actually does kind of stand out, I will go and I will fight for you to our PM to see what his expected reaction was. But for the most part, every app has a solution here, and it's not that difficult. So this is my whole 30-minute talk. That's 15 minutes while I'll be standing right here, and you can come say your mean things or ask me your really good questions. But I hope you guys have a great day, and thanks for listening.